Welcome to This Explainer. Okay, we're diving straight into one of the most profound mysteries hidden in our source material today. How on earth does our totally chaotic universe actually organize itself? I mean, look around. Galaxies, ecosystems, you and me, we're these magnificent structures that have somehow just assembled themselves out of nowhere. So today, we're unpacking the physics of spontaneous order. We're going to trace the deep connections between mathematical chaos, the absolute miracle of synchronization, and ultimately the biological mystery of life itself. Right off the bat, we are facing this massive cosmic paradox. You know the standard laws of physics? They tell us the universe and any isolated system in it is on a one-way street sliding straight toward a state of increasing disorder. Think about dropping ink into a glass of water, right? It mixes, it disperses, and it literally never spontaneously unmixes. Yet somehow, against this massive cosmic tide of decay, here we are. We exist. We see this purposeless flow of energy wash life, consciousness, and just staggering complexity right into the world. How does that make any sense?
Well, it really comes down to a battle of forces. On one hand, you have entropy, the notorious second law of thermodynamics, constantly pulling everything toward chaos, randomness, in a totally featureless equilibrium. But in direct opposition to that, we see spontaneous order. We see the exact perfect geometry of snowflakes forming in the sky. We see fireflies flashing together in the dark. We see the crazy, intricate architecture of living cells. The source material reveals that this isn't magic, guys. It's actually a fundamental drive of nature. It turns out that dissipation and randomness, when they're given a little bit of direction, can act as agents of absolutely incredible order.
Which brings us to Section 1, Hidden Order Within Chaos. So picture this. If you watch two tiny bits of foam going over a violent waterfall, standard physics says their starting point at the top is utterly unpredictable by the time they hit the bottom. For a long time, scientists just assumed that to get complex, random-looking results, you absolutely needed complex, random causes. Makes sense, right? But in the 1960s and 70s, this creeping realization took hold. They figured out that super simple mathematical equations can model systems that are every bit as violent as that waterfall. Tiny, microscopic differences in the input can become overwhelmingly huge differences in the output. You probably know this as the butterfly effect. But hidden right inside all this wild unpredictability was something truly astonishing. And that brings us to the concept of the strange attractor. This basically proves that even in pure, unadulterated randomness, nature is constrained to an orderly, unchanging essence. See, when pioneers of chaos theory mapped out the behavior of wildly unpredictable systems, like turbulent fluids or the weather, the data didn't just scatter everywhere like you'd expect. It actually traced a distinct shape, a lot of times looking exactly like the two wings of a butterfly. The system never exactly repeats itself, which is pure disorder, but it always stays within certain boundaries. It just loops around and around forever. So chaos, it turns out, actually has a tightly constrained, highly structured skeleton.
Moving on to Section 2, the miracle of sync, order in time.
Mathematician Steven Strogatz's research on this is just phenomenal. He reveals these breathtaking examples of completely mindless entities spontaneously falling into perfect lockstep. I mean, from the vastness of the cosmos all the way down to the subatomic realm, we see this unbelievable coordination. The moon's spin, perfectly locked to its orbit around the Earth. Millions of pacemaker cells in your own heart, firing perfectly together right now to keep you alive. Out along the tidal rivers of Malaysia, thousands of male fireflies will flash in this silent, hypnotic unison with 0 leaders and no cues from the environment. Even in technology, you've got trillions of electrons marching in lockstep to create superconductors. It's like the universe literally has an overwhelming desire for order. But how does that actually happen? To understand how thousands of fireflies flash together without some tiny little conductor telling them what to do, we have to look at the underlying mechanism: coupled oscillators. Now, an oscillator is simply something that repeats its behavior in a cycle. Think of a flashing firefly, a firing neuron, or just a swinging pendulum. They're considered coupled if they can somehow influence each other's timing. And nature uses literally every available channel for this communication. Fireflies use light, planets use gravity, and your heart cells pass electrical currents. Let's look closer at that in Section 3, how oscillators couple together, fusing into one. So Japanese physicist Yoshiki Kuramoto provided an absolutely brilliant mathematical model for this. It's best visualized if you picture a group of joggers on a circular track. Imagine they all have slightly different natural running speeds. Kuramoto's rule is basically this: the leading runner slows down just a bit, and the trailing runner speeds up. Each runner constantly observes the pack, computes a quick velocity correction, and then adjusts their pace.
through just these 3 simple steps of constant, instant-by-instant mutual adjustment. Observe, compute, adjust. A tightly synchronized pack seamlessly emerges from what was just a totally scattered crowd. And this constant adjustment leads to a really fascinating threshold. When this mathematical phase transition happens, the system's order parameter shifts. It goes from 0, which means complete random scattering, straight up to a perfect 1.0. That means complete unison has abruptly snapped into place. Strogatz actually notes this is exactly like freezing water. You lower the temperature of water and suddenly trillions of randomly tumbling liquid molecules just snap into the rigid, perfect lattice of solid ice. Sync is essentially the exact same thing, just freezing in time rather than in space.
This takes us to Section 4, Lifting the System Veil, Perceiving Order.
Researcher Eli Adam formally defines this phenomenon as generative effects. The absolutely crucial point to grasp here is that when complex systems interact, emergent behaviors arise that you simply cannot see if you study the systems in isolation. You can't just dissect a single firefly in a lab to find the secret of the entire swarm's synchronized flashing. It doesn't work that way. The beautiful, organized output of the group is fundamentally different from the sum of its chaotic individual parts. Adam conceptualizes this as a sort of veil. On one side of the veil, we have what he calls system space. That's the hidden, highly complex, chaotic internal wiring of the world. But on the other side, we have phenome space, which is the beautiful, synchronized output we actually get to observe. Sitting right between them is a mathematical mapping that Adam calls the veil. It completely hides those complex internal mechanics and basically forgets all the microscopic chaos. It leaves only the synchronized phenome visible to us. It's literally how the universe filters its own underlying turbulence into a coherent, livable reality.
And finally, Section 5, Life's Aperiodic Crystal, the ultimate mystery.
This brings us to a massively powerful realization by the quantum physics pioneer, Erwin Schrödinger. He noted that living organisms are essentially miracles of pattern. They constantly disturb the universe's natural tendency toward equilibrium. Because, think about it, while everything else in the universe is sliding downhill toward maximum entropy and decay, life alone manages to actively suck orderliness from its surroundings. We sort, we build, we metabolize, and in doing all of that, we propagate structure against the absolute odds.
Schrödinger posited that the core building block of life had to be something he called an aperiodic crystal. Now, unlike a plain, repetitive ice crystal, which just repeats the exact same dull structure in 3 directions over and over, the building blocks of life hold profound complexity and structure, but without that mindless repetition. That aperiodic, non-repeating nature is exactly what makes it so incredibly special. It's really the difference between plain wallpaper and a highly complex woven tapestry. Our DNA is an aperiodic crystal. It's a structure that allows for the infinite complexity of chaotic systems, but tightly bound into a highly synchronized, profoundly orderly form.
Which brings us to a truly staggering realization. We started this whole explainer by asking how life and order could possibly exist in a decaying universe. But as we've just seen, chaos inherently contains order, and coupled oscillators mathematically guarantee synchronization. So if even lifeless equations inherently strive for spontaneous order, is the miracle of life merely the universe's overwhelming desire to synchronize? I'll leave you with that final thought to contemplate the next time you feel your own heartbeat, a staggering mathematical marvel of perfectly synced cells born completely from a decaying universe.